Welcome, Algebra 2. Let's take a look at Chapter 6, Section 4, transforming graphs of exponential and logarithmic functions and writing those transformations. You're going to start off with a little Desmos activity called a marble slide. So let me demonstrate how that works. These are pretty fun activities, but you will get to know exponentials as you play around with it. So for starters, you're going to see a pretty weird looking graph, and there's some stars and a purple ball here. When you launch the ball, the goal is to take out all the stars. Now we took out those three, but then the ball drops down and takes out the remaining one. And you've got to do it before time runs out too. So you don't have an unlimited time for it to go. It's got to be the right angle, got to be the right shape, right areas. First one that you do, it says change one number in the row below to fix the marble slide. Maybe that's the 2. Maybe it's not supposed to be a 2. Maybe it's not supposed to be a -5. Maybe it's a +5 or a -3, or I don't know. Maybe it's not an x, maybe it's a 2x or a 1/2 x. So there's 3 places there it could be. If you totally goof up, you can always go here where it says edit list, and you can hit reset to start all over again. But if I launch right now, I can clearly see I do not take out all of the stars. I've got to fix a number to make it happen. You can always reset if you need to. Now, getting a little tougher, change 2 numbers in the row below to fix it. The first part gives you the equation, 2 to the x minus 1. So you're going to change a number there. The second part says x is greater than -7. So that's constricting my graph from here, -7, over to here. There's no graph that exists here. You're going to have to adjust that number to make it fit so that way you can get all the stars. Because if I launch right now, I clearly do not get all of them. It's almost like it needs to be raised up and maybe a little bit longer. Hint, hint, hint. Good luck. Have some fun with that. If you work with a partner, and you should, put both of your names in. Hit pause until you're ready to come back to your notes in about 15-20 minutes. All right, welcome back. We are in Chapter 6, Section 4 today. Graph paper is over by the calculators as always. Let's take a look at how to graph transformations of exponential and logarithmic functions. We'll start with e to the x. E to the x is our parent exponential function for e. And then you're going to be changing that around to have other functions also. How do we graph it? Well, just like we graph anything, we make ourselves a little XY table. I would normally be putting it on the board, but since I'm not here, I'll put it over on the graph, and then I'm going to have to erase it at some point. So be sure you copy it down. But we'll pick some x values, plug it into e to the x, and we'll get our y values. So maybe -2, -1, 0, 1, and 2. Those are our typical numbers that we plug in. You break out your calculator. Your E button, in case you've forgotten, is over here. It is second ln. It's next to your ABC button. So second ln gives me E exponent -2. I got 0.135. E to the -1. I got 0.367. So we'll call that 0.4 if I round. E to the 0, well, anything that's 0 power is 1. E to the first would be 2.7, 1828. We'll call that 2.7. And e to the second power, well, 7.38. We'll call that about 7.4. Just doesn't want to write over there. If I plot my points, -2, I am really low, but not quite at 0. -1, I'm almost halfway up. 0, 1, there we go. 1, 2.7, and 2, I'm at 7.4. Yours will fit, your graph goes up to 10. Mine only goes up to 7. Draw our curve. We have our exponential growth. So how would you then graph something like e to the x plus 2 minus 1? Well, using transformations, we realize that one of these numbers moves us left and right, one of them moves us up and down. This is down 1 unit. Every point is going to go down 1 unit. But what does the plus 2 do? Well, it's here with the x, and that moves us left and right. This will move us left 2 units. So if I could take every point, move it down 1, left 2, I'd have my new graph. Here's a point. Let me take it and go down 1, left 2. There's my new point. Here was the point. Let me go down 1, left 2. There's my new point. Here was a point at 0, 1. I go down 1, left 2. There's my new point. At 1 and 2.7, I go down 1 to 1.7 and left 2. And lastly, we were up here at 2 and 7.4. Didn't quite fit on my graph, but now because I'm going down 1, I'm at 6.4 and over 2. There we are, big blue. Here's my graph. Transformations. Left, right, up, down, stretch, shrink, reflect. Same ones we've seen all year long. So how do we then graph natural log of x? Well, natural log, if you look on your calculator, you find your ln button on the left-hand side. What is above it that you have to press second to get to? Find your ln button. E to the x is above it. Therefore, they're inverses of each other. If I take every point that's on E, this graph, the red one, and I mirror it, I'll have the inverse. So let me do the inverse now. The inverse, instead of -2 and 0.1, it would be 0.1 and -2. Instead of -1 and 0.4, it'd be 0.4, -1. Instead of 0, 1, 1, 0. Instead of 1 and 2.7, 2.7 and 1. 7.4 and 2. That's how we're going to graph our inverse function. We take every one of these points, we flip it. So let me get rid of those, get them out of the way, so I can draw my inverse graph. 0.1 would be over just a teeny bit, down to -2, trying not to touch the y-axis. It's really, really close though. 0.4 would be almost halfway for x, down to -1. 1, 0. 2.71. 7.4, 2. And there's our inverse function. The red one doesn't cross the x-axis. The green one, its inverse, doesn't cross the y-axis because they're inverses of each other. Those things that they don't cross, they switch when you switch x and y. Our domain and our range will switch for those two when you switch x and y. Why do lumberjacks prefer natural logs? Because the wood cuts more naturally. Natural log, ln and e, get it? Why do lumberjacks make good musicians? Because of their natural logarithms. Beware of log, okay? Beware of log. It will bite. You and your group spend about 15 minutes trying to identify transformations. So what you have is a series of equations and graphs. And it says use Desmos to help match each graph and its function. then describe the transformations from the original function, e to the x, or natural log of x. So, 6 equations, 6 graphs, match them up, and then describe the transformations. Take about 15 minutes, no more. Pause your notes, come on back when you're ready. All right, welcome back. The last thing that you're going to look at is a Desmos activity on exponential and logarithmic functions. If you're going to work with a partner, of course, you would put both of your names in. Here's how it goes. You'll be exploring the graphs of different exponential and logarithmic functions, like all of these. Use a calculator to evaluate e to the x. Fill in the table. So this is kind of what we just did, right? E to the negative 1. I got 0.3678. So I'll call that maybe 37. E to the 0. Keep going. Fill it in. Now turn on the graph of y equals e to the x to compare it to your points that you plotted. So you'll turn this on. Your graph should go through the points that you plotted. Hey, what do you know? I got the first one right. You'll have the rest of them that'll be correct also. Since e is approximately 2.718, does y equals e to the x or y equals 2.718 to the x represent exponential growth or decay? You can look at the graph to explain it. You could describe it based upon the size of the base. We learned about what is growth and what is decay. Now you're going to do the same thing for natural log of x, ln 0.1, ln 0.5. Turn it on, see if you get it right. Play around with it, have some fun. I'll see you guys next time around. Bye, guys.